Okay. Hello, everyone. Welcome to 2021 P4 workshop. I'm Guru Parulkar. I serve as the Executive Director of Open Networking Foundation and also Executive Director of Stanford Platform Lab at Stanford University. I'm going to help coordinate this recorded session about programmable data planes for converged access infrastructure. I'm delighted to welcome two of our distinguished speakers from Cisco, Murali and Praveen. Actually, Murali is the one that is going to do the talk, and Praveen is going to help us in the discussion at the end. Let me do quick introductions of Murali and Praveen. Murali is the principal engineer and architect in the mass scale infrastructure group at Cisco, working on next gen products with a focus on mobility, wireline, and cloud technologies. He was the lead engineer on multiple generations of service provider platform developing ASIC architectures, validation, and software design. Murali also actively participates in 3GPP and university research via Cisco Research. Murali holds MS in computer science from USC and ISI. Okay. Next, Praveen. Praveen is a fellow in the mass scale infrastructure group and has been at Cisco since 1998. He is responsible for the architecture and design of software and systems that power some of the largest and advanced networks in the world. Praveen currently focuses on the software innovations in the areas of next generation routing platforms, fixed mobile convergence, and software hardware disaggregation, including the adoption of Sonic on the Cisco 8000 series of routers. So again, Murali and Praveen, thank you so much for participating in the P4 workshop, and I'm looking forward to your talk. With that, Murali, please take it away.
Thank you. Thank you, Guru. Thank you, Michelle. Good morning, good afternoon, good evening, everyone, depending on when you're going to watch the video here. Thanks, ONF, for hosting the event. Hope you're all well. Thanks for the opportunity to participate and engage in a dialogue to share a few thoughts on the topic of subscriber access convergence, primarily P4 runtime. Today, our talk is about the subscriber user plane in the access, how we see that evolving, and what aspects of P4 would be applicable to shape this kind of going forward. Specifically, we talk about wireline, mobile, and cable subscriber user planes in the context of this conversation. So we kick off today's topic with a short background on some of the features that drive this convergence and the drivers for this convergence. We explore this with an approach based on a combination of software, say FIDO VPP, and hardware P4 enabled in what we call a hybrid model, with a goal of optimizing the solution across multiple dimensions, including cost, power, throughput, and functionality. To give you a little bit of a background, subscriber access technologies and products across wireline and mobile and cable have traditionally been delivered using hardware-centric, siloed, vertically integrated stacks across each access technology. Traditionally, these data planes for each of these technologies were built using ASICs and NPUs with a combination of fixed and custom programming models and software. With the proliferation of cloud services to the edge, disaggregation in radio, transport, and subscriber technologies combined with a push towards convergence across various access technologies, we are looking at massive transformations. A key component of this transformation is the evolution of the data planes for these subscriber access technologies with the advances in compute, SmartNICs, NPUs, DPUs, CPUs. So the question is, how do we drive towards this converged user plane for subscriber access? And the common infrastructure services need to be shared across these domains of wireless, mobility, and wireline and cable with the hybrid model, and with the goal of realizing that we want to balance features versus performance, enabling flexibility, elasticity, while reducing overall cost. And the answer is yes. In this talk today, we are going to focus on calling out the user plane, converged user plane, gateway functions, subscriber gateway, all to loosely mean pretty much the same for purpose of simplicity. In this next slide, really, if you were to look at a macro level, subscriber access convergence can be realized in one or more ways. If you look at going bottoms up in the slide, the CUPS architecture model as defined by standards could be considered as your protocol convergence layer. Think of market-specific VPNs in silo across cable, mobile, and wireline, now on a unified or a consolidated subscriber access gateway running on-prem or on the cloud. The control plane is unifying policy on-prem or on the cloud. If you look at infrastructure, infrastructure convergence is characterized by cloud-hosted and cloud-as-a-service enabled software delivery models via automation. One can envision service-level convergence across common policy, automation, or unified backhaul for transport. Business convergence is driven by the need to have multi-homed access for the end customer. Think of it as cable plus mobile or mobile plus wireline or all three for redundancy. This is further accelerated by the economics of the operators to minimize TCOs. Let's step back and kind of look at what the standards are saying, and we reference the standard model here for fixed mobile convergence. BBF and 3GPP, along with Cable Labs, are all aligning around 3GPP spec, really 16, 17 going forward. Briefly, if you look at it, fixed mobile convergence was born out of the desire to use fixed and mobile assets more consistently and effectively to provide for multi-access connectivity for customers, as well as to reduce operational complexities across the network systems. The justification is in specific areas, such as being able to provide better service experiences, network and IT optimization. Technology advances in SDN and NFV enabled virtual and programmable converged control network functions, allowing providers to reduce TCOs. It simplifies and unifies the design of network and decouples the service implementation deployments via CUPs. Primarily, the standards are governing the ability to have a common control plane, a common unified access platform, and a converged core, whether it is used standalone or interworkable for coexistence. It also defines some common network interfaces in order to provide for, in the context of wireline and wireless convergence. In case of residential gateways, the access gateway functions helps adapt the fixed access onto the 5G core and extends the 5G core control plane to the home network and vice versa. You have 5G residential gateways also trying to leverage the control plane to enable new services. This is primarily the view of the fixed mobile convergence as proposed by standards. If we extend the standards and think a little bit holistically, you can take a much broader view of what convergence looks like. We can really unify cable, BNG, mobile, and even wireless LAN for true and an architectural convergence once we solve all these issues a little bit more comprehensively. There are some aspects to this. At the application level, you obviously have IT backend and service convergence, which makes sense. But more importantly, at a network level, with convergence, we can leverage combined transport, combined packet core with a single breakout to the internet. The converged user plane can take the form of either an AGF or a BNG user plane or just a UPF. Subsuming all the access types, then we start to look at a Swiss Army knife solution for this user plane that will have to be flexible, fast, feature-rich, and scalable. Convergence now seems inevitable given that this possibility is almost real. The common user plane platform satisfies the standards requirement for all the verticals. Therefore, convergence is inevitable. A second aspect of this is the facet of the changing nature of the internet traffic. We all know, and there's been measured in multiple papers, published in multiple papers. Cisco has talked to our customers. We have measured it. We can distill this all into a few guiding principles. And there are some interesting data points. If you look at the picture on the right, the two concentric circles represent a couple of things for us. And to add to that, we have bandwidth demands that are going up. I mean, one of the highlights is essentially the average connection speeds on a fixed wireless access is going 100% every couple of years. And with 5G, it's beyond 10x. And with the increased speed, we're also seeing that if you look at the picture on the right, we are not connecting to a lot of the websites. Major origin is coming from relatively few content originators and aggregators here. And people can potentially get a lot of the content from few sites with a long tail to snack on for the relatively disparate number of websites that are out there. That's an important data point because tonnage is coming from relatively few originators. Thirdly, and most importantly, the majority of the traffic, the order of 90% or so, is natively getting encrypted. What this means is we need a lighter, differently enabled packet manipulation techniques going forward, since there's really little in value in attempts for discrimination when the client and server sessions are secure. Whatever is the content, video, images, or even IP controlled traffic. This is because of advances in TLS 1.3, DNS over HTTPS, and QUIC, which is obfuscating the need for really DPI. So there are some takeaways out of this. Internet traffic is changing. We need observability, steering, features that will still need to be managed in all the access technologies. The internet traffic is increasing. Throughput increases, cost savings will be required, among other things, efficiency. There is a significant uptick in latency sensitive applications as well. All access technologies, we believe, are seeing this, which means changes in feature improvements will need to be required across the board. Convergence is just a natural step along the way for us. If you look at the key drivers which come to fore all the time, the triumvirate of cost, power, and features, we need to operate in areas where we have core, edge, or far edge deployments. Mostly they are power and space constrained, with power really becoming a critical element of network design in several POPs. We need to deliver nifty high-value features, not just connectivity or tunnel termination. It includes flow offloads, support for traffic management and steering, lawful intercept capabilities, along with accurate charging and billing. Together, we need to have a solution that is high-performing and resilient. Use case specificity of features and speeds and feeds become super important. We believe to solve this, a hybrid model with software and hardware combination is the way forward to really address the needs depending on the use case. So putting it together, what we want is faster session throughputs, reduced endpoint scale, and differently enabled packet manipulation capabilities that results in improved cost for us, right? If we double click on this further, an architecture model can be conceived something like this. If we dig a little deeper here, the control plane policy is a unified engine that needs to primarily do session anchoring across all of these domains, together with transport and tethering capabilities and telemetry. It needs to be either on-prem or on the cloud. Digging a little bit deeper, you have the user plane, which is access agnostic, and that can subsume any of our tunnel technologies for these three domains: GTP, PPPoE, L2TP, or IPoE, together with a complex set of services that we need to drive that include primarily header enrichment, CDN acceleration, telemetry, ADC or application detection, some aspects of firewall and security, together with enhanced billing. In short, our proposal is essentially to do a divide and conquer in a way that we can stitch the components of capabilities on a compute infrastructure and do a few things differently using capabilities in a SmartNIC type of an ecosystem that has a plugin with a SmartNIC or NPU, okay? This combination is primarily can be done with general purpose compute and the SmartNICs we are talking about. And the glue to all of that is to drive it via P4 and P4 runtime. P4 with its programmability and extensibility is a useful tool to implement the functionality that will be hardware offloaded towards the NPU or DPU. And the runtime is used as an interface between the compute infrastructure and the offloaded functionality that we are talking about. With this, you potentially get power and efficiency and speed with P4. And with the software forwarder, you get the flexibility and far more number of resources in terms of memory and other things. And the runtime really forms the glue for intelligent and coordinated control of both of them. You can think of it conceivably as the ability to reprogram the P4 tables when new things are enabled or learned, potentially reprogramming the pipeline if you want to get really radical. And you could also reprogram the software at the same time to complement the P4 hardware. So we want the common user plane platform that satisfies the standards requirements of the verticals. This just requires standards that are considerate of each other to build a converged user plane. If you really look at this, the bottom line is we are on a journey where we need to continue to enhance high-speed packet processing with the cloud computing infrastructure and abstractions and drive it with P4. Some rethink is needed in terms of how we want to drive this, with the goal that we want to achieve performance scale on a hybrid infrastructure. We need to still be able to deploy the NFs with efficient isolation mechanisms without losing some generality. We need to stitch these NF chains with an efficient yet standard scaling mechanisms. We also need to enable these NF chains to coexist with other applications while still meeting the SLAs. We want to drive the synergy in this common architecture and use the strengths of P4 and P4 runtime. And what are those really? Let's double click on that a little bit further. We primarily feel there are two areas which we will continue to evolve to make the solution complete. Flow management and service tethering is an important aspect of the solution. Telemetry and monitoring is another dimension that's super critical. Flow management in the programmable data plane, given that the internet is going dark, needs some new thinking and different approach. It also needs to, at some point, subsume some aspects of security and traffic service steering capabilities, broadly speaking. There are many layers to flow processing that includes protocol mixes, session lengths. We need a focused effort, really, to define the offload API between the user plane functions running on the compute and the components running on the NPUs and SmartNICs we are talking about using P4. There is variability of flows. There are stateful flows, there are stateless flows, there are short and long-lived flows. We need engines in the subsystem to also ensure we have the capability to do better flow pacing and proxying to augment differential flow processing for the subscriber, especially when we want to optimize for uplink capacities that each of these will have. This is an area of further work. We talked a little bit about the changed approach to packet manipulation due to encryption. We can't optimize or continue to optimize what we are doing right now as traffic continues to change. We need these new techniques, and we need to make sure that P4 in conjunction can address those. What we mean by that is we need to bring in aspects of AI and ML into the solution for application detection, potentially doing the header analysis and other aspects which can have a faster feedback to minimal latency on the packet processing. In a converged user plane where we are in the middle, we are governed by our privacy aspects. We can only observe and glean, and we have to model that into active rule sets for better offload processing. We potentially see SmartNICs, NPUs, and DPUs going forward, subsuming engines for GPU or TPUs as well to accelerate for ANNs, which further then need to be enabled with P4 or P4 runtime with SDK enhancements for leverage. This is an area of further work, and we have seen active research in this domain, wherein you can take an ANN and disaggregate pieces of that to run on a compute versus what can run on a SmartNIC capability between the layers of the ANN. If you click into telemetry, clearly in-band telemetry, streaming telemetry, event telemetry, these are all aspects that are super important for our service provider customers to have high visibility. Really, they have to be multi-layered, probabilistic, sampled, with various approaches to broaden the coverage and visibility. We need an ability to compress and enrich the telemetry information and reduce volume where required. These user plane functions need various tap points in the hybrid system to be exposed to ensure visibility. We need fine-grained control, monitor subscriber capabilities, generations of high-value CDR, EDR, URRs by eliminating noise. In-band telemetry has been an area of work in the P4 community for the past couple of years that can be leveraged for the converged user plane to close the loop. because this is a super important aspect of the solution. We need it to essentially be capable of observing, analyzing, reacting, and reprogramming, all done seamlessly. So these are two kind of key areas where we feel further work and leverage from P4 is absolutely critical. To round it out, what we are doing is we are building a solution with flexible hardware and software using the advantages of both to deliver more than either can do by itself. P4 and P4 runtime can really align with the needs of the user plane as we evolve this. There are many layers to flow processing. We need a focused effort to define the offload API between the user plane functions on the compute and the components on the NPUs and SmartNICs. Vendors have developed tools for auto-generating a lot of the P4 APIs or APIs from P4 programs, but we need agreements on how to define these APIs and which language constructs to be used to implement them. We need to guarantee portability across multiple P4 targets going forward. P4 runtime would continue to include and drive switch management, port management, and now traffic and flow management also to ensure that we solve this problem. We believe the hybrid approach for subscriber access converged user plane is the way forward. And there is scope for standardization here in the industry, and Cisco would be interested in participating and driving this conversation forward. Thank you.
Terrific, Murali. Good talk. Definitely, you made a very good case for convergence and how we can use programmable data planes in that converged architecture and solution. So that's terrific. So let me start with maybe a simple question first. You didn't say anything about the state of this work in the context of Cisco. Again, I don't know what you can say and cannot say, but I want to make sure that I ask you the question on behalf of the audience and give you an opportunity to be able to say what is the state of this work that you presented inside Cisco. Is it primarily research and exploratory? Is it something that is almost committed to a product and we can expect that in Cisco products going forward, or something else? So please tell us, what is the status of this in Cisco?
Praveen, you want to go ahead with this, or you want?
Yeah, I can take that, and please chime in, Murali. So that's a great question, Guru. So this is definitely an area we are actually exploring. I mean, the key here is to identify what are the right use cases and what kind of flows would be the right targets for the offload, and how the the software user plane and the P4 enabled user plane can coordinate for this offload. So at this point, I would say this is more at an exploratory level. We're talking to a few customers, understanding the use cases. And this is, as Murali pointed out, this is definitely an area where we believe having a common approach or a standardized approach to both the use cases as well as the APIs would benefit the industry quite a bit. But yeah, that's where we are at this point.
To add a couple of things in addition to what Praveen mentioned, clearly the SmartNIC ecosystem is also evolving going beyond Gen 1 and Gen 2 version of their own architectures, right? I mean, that progression of work is heading towards unifying this using this common API abstraction primarily, right? Otherwise, we'll have a lot of siloed platforms down the line.
Okay. So because you mentioned, you are working with customers and trying to understand the use cases, I want to ask you another question about the priority of convergence for service providers or network operators. On one hand, our experience at Open Networking Foundation has been that on one hand, operators also see the value of convergence, and in many ways, this is like a holy grail for them. However, when it comes to prioritization, it appears that they are very busy with 5G, deploying 5G, scaling 5G on one hand. On other hand, they are wanting to deploy GPON, XGS-PON, and all of that. So the convergence, even though it's very interesting and they see the value, it does not get the necessary priority. So I wonder, what are you seeing when you're talking to your customers and service providers generally?
Yeah, it's a great one, Guru. So you're right in the sense that convergence is an interesting topic, but the way I would look at that is there are several levels of convergence. right? And I think as Murali briefly pointed out, there is convergence at, can I commonize on the infrastructure elements that are used, like whether that is the compute infrastructure or the CAS infrastructure on which you initiate the different session managers, like one for wireline, one for mobility, one for cable. Is there a and then there could be convergence at a policy level where you still have disparate control plane and user planes, but you have a common policy, a common subscriber ID that is tying all these different implementations together. And then a true protocol level convergence, which is kind of what is being driven in BBF and 3GPP with the AGF as the anchor point for access, for bringing in the access and then using a common UPF. So I think I would say our experience or what we are seeing is very similar to what you have alluded to, Guru, in the sense that there is definitely a lot of interest and there's a lot of participation in kind of defining the different elements of convergence. But at the same time, different customers are at different levels of onboarding 5G and onboarding different aspects of convergence. So I think it's going to be a journey. I believe most of the SPs that we have talked about are thinking about the problem in the right direction, but each one has their own path and timeline of when they get to what aspect of the convergence. But I truly believe that it's going to be a journey where different levels of convergence would be attempted. And once you have the backend type of convergence and the policy convergence and so on, the actual protocol convergence would follow that, hopefully sooner than later.
Mm-hmm. Okay, and good. So I guess you talked about this separation of data and control plane, the CUPS kind of standardization and all of that, and then also kind of the fixed and mobile convergence, and different standards organization are working on that. And now in that mix, we are putting in a programmable data plane, and as you said, so now there is a need for some standardization or something between this programmable data plane and whatever the software user plane that is separated from the control plane. So, and you mentioned P4 runtime and P4 and all of that, that's great. How do you see we bring some of these standardization into this converge mode of fixed and mobile convergence for some of the use cases you talked about?
Yeah, I can start that, Murali, and chime in. So that's a good question, Guru, because traditionally, there are two ways that one could approach the standardization. Right? One is the going into the standards bodies and then coming up with a proposal. The other model is having a small group look at a few use cases, come up with a particular implementation, try it out in the industry, and then slowly build on top of that. I mean, if you look at how P4 and P4 runtime have evolved in general and how we are seeing some of the convergence use cases also evolving, I personally believe that the second model is more apt for something like this, where a small set of players, I would say combinations of ONF and some vendors and some SPs coming together, defining this, maybe coming up with a version 1.0, version 1.5 type of implementations, and then slowly evolving that. I mean, the good thing with something like P4 and P4 runtime is it's a lot easier to build that incrementally rather than having to define the entire set of use cases together. And also, it's very use case driven, right? So, what we don't want to end up is spend the next 5 years collecting 50 different use cases and then going with a standard, but rather pick the 2 or 3 most valuable use cases across the market, build what is needed for that, test it out, deploy, and then bring in the additional use cases and evolve the standards. And obviously backwards compatibility becomes important, but with things like protobufs and gRPC and P4 runtime, some of that is already taken care of with most of the the software stacks and APIs today. So I see the right way to move forward would be making that incremental approach towards convergence, towards standardization. And anything, Murali, that you would add?
Yeah, absolutely. I think I completely agree with what Praveen mentioned. We need to build a solution a little bit more organically, grounds up from a fairly a simplistic view of deployment. If you look at, for example, enterprise 5G, some of the requirements there from a use case perspective are a lot different when you look at as compared to a consumer internet, connectivity and mobility, which is a lot more feature heavy, a lot more features that are out there. So we have to skin the problem on a use case by use case basis, but we want to build it a little bit more organically with a small, grounds up focused approach here.
Terrific. I guess we agree with you wholeheartedly. So we hope we find a way to bring that community together and extend P4 runtime and all of that for the converged use cases that we are talking about. One more thing that in your one of the slides that you showed a server and you showed a NIC. And I can imagine that in certain contexts, that is the right way to implement this convergence that you're talking about. But you left out the switching systems completely. Maybe I overlooked it, or that's not what you meant. But wouldn't you think that in many cases, it may be actually, if you think about it, it may be virtual machines or containers running in a virtual environment. So there is a virtual switch, then there is a smart NIC, then there may be a programmable switch, and then back down again there's smart NIC and an overlay switch, and then the container or the VM. So is that the end-to-end pipeline that you see, or am I missing something when you say NIC and the server and nothing in between?
Yeah, a simplistic view of that is a collapsed environment. You have a server with a smart NIC embedded with it, right? So that picture that we were trying to show is essentially something like that, right? That we are having a unified system with a host-based, forwarding engine, as well as a NIC-based forwarding engine running primarily smart NIC or an NPU type capability, right? The other aspects are all, variations in how we want to build using any of these pieces of infrastructure in some sense. So between your host and your NIC infrastructure, we want to make sure we have a runtime infrastructure with P4 to essentially do the offload processing that we want on the NIC capabilities. So that we need capabilities.
Yeah, oh, definitely. I was just trying to say that if we are looking at bigger BNG implementations or combination of BNG with the mobile core, there may be a switch involved, and then there are a bunch of servers with smart NICs, and the environment will be a combination of servers, smart NICs, a programmable switch, and then you're trying to carefully balance, taking advantage of each one of them depending on what they can offer. So is that something you would think about it?
Guru.
Absolutely.
No, that's absolutely true. Actually, if we double down, if we kind of take a deeper look at that slide, it does, obviously it's a simplistic view of all the different possibilities, but it does talk about a smart NIC or an NPU as the offload target for the P4 enabled portion of the user plane. And in this sense, the NPU is like a generic representation of a switching system. It could be a single fixed switch. It could be a large modular chassis. It could be a network of NPUs. All of this are definitely in the realm of possibilities, depending upon the use case and the scale. And to your point, how do we want to load balance the sessions across different endpoints, for example? Yeah, that's a good observation and a very valid point.
And so I'm just in the same context. So are you, if at all you're starting to build the system, are you also looking at Silicon One as, that silicon is very powerful, it is P4 programmable and all of that. So putting it together with smart NICs, or you have not gone that far in the context of this use case?
So I would say, obviously Cisco is investing quite a bit into Silicon One, as you know. So yeah, that's definitely part of our overall solution. And in different form factors, depending upon how it is evolving. Right now, we have the Cisco 8000 platforms being built with Silicon One, and then in the future we're also looking at potentially a lot of this really depends on how the market evolves, and this is where the incremental nature would really come into place, is to find out what are the different form factors in which that offload engines would be consumed by the market, and then we'll kind of follow that.
Okay. Maybe my last question, and this is my standard observation sometimes, you mentioned AI ML, and I'm trying to see how seriously you're seeing that, or whether you're seeing that kind of casually, because the challenge we are seeing, I don't know whether you're familiar with Keith Winstein's work at Stanford. You may want to take a look at it if you are not, where what he's finding out is that applying AI ML in networking systems turns out to be extremely hard, because what happens is that there are lots of good papers, there are POCs in fact, and all of that that show the promise or potential of AI ML in networking systems. But networking systems, when they are in a deployed environment, and especially when you're trying to bring up new applications and new systems, predicting the traffic patterns and being able to train those neural nets and all of that turns out to be very, very hard. And as a result, creating predictable behavior and performance from these AI machine learning systems in networking environment is very challenging. So I'm just wondering whether you said that, kind of that is, there are potential, but you see the challenges, or
Yes.
am I missing something?
No, you're absolutely right in that observation, Guru. It's a non-trivial problem at this point in time, right? Clearly, we need to have a further definition of what is possible and some experimentation around that. But what we fundamentally said was that if you were to do that, the SmartNICs would need to subsume those kind of engines into the aspects of the SmartNIC ecosystem, so that now that is an entity that can potentially be leveraged once that problem is actually well understood and solved. So I did mention that that's an area of further study and work, which is clearly where we are all at this stage in the game. If we really want to stitch that into our packet processing capabilities with the ability to do some kind of deep learning all on hardware, we need some more work there collectively as a community here.
Okay, very good. Anything else? Any question that I should have asked and didn't ask?
I think you covered all the major aspects of what we were trying to say, and I think thank you for pointing out to some of the COMAX work that you guys are undertaking in ONF, and it's something that we should definitely double click on and engage with the team on your end, and maybe collaborate to help define that further and go forward here.
Love to do that.
Yeah.
Okay.
Happy.
Okay, so again, Murali and Praveen, both thank you so much for a very insightful talk. And I'm a huge fan of Convergence. I really hope we can pursue it together, and the operators will prioritize it and want to deploy a converged solution. That will be really great. Okay, with that, thanks again. And Michelle.